Did you guys have a chance to print out the note? So after I say hi to you guys. So now let's go straight to the lesson. Okay, so today we're going to talk about difference of two square. Okay, so when you have a square subtracting a square over here. Okay, so first notice that if you have a minus b times a plus b, okay, if you multiply this out, so you have a squared, right, and then plus ab minus ab minus b squared, and these two, they cancel out and leaving us with a squared minus b squared, okay. Now, so when you multiply this difference of a and b with the sum of a and b, we got difference of two squared, which is a squared minus b squared, okay. This is called multiplying out. And if we go backward, we can factor a squared minus b squared as a minus b times a plus b. So this is called factoring. So if you get difference of two squared, we can factor that into the difference of the base here times the sum of the base over here. Okay, so that's a pattern. Now before that, I'm going to challenge you guys with the perfect square, because if you can recognize those perfect square of numbers, then it's going to help you with the factoring. Okay, so what is the square of 10? Anyone? 100, right? 100, I got this one. Okay, 11. Let's keep on going. 121, right? Okay, good. I'm looking at the chart also. There. You can enter the in chat. Yeah, 121. Next one. There's the challenge. Is what? 144, yes. And then next one. 169. Yes, you got it. Okay, good. And the next one. 196. This one here, I just remember the pattern. See, 169 and then this 196. Switch this two. Okay. 15 squared, it is 225. Okay. 16 squared is what? Anyone remember this?
56.
256. Yes, you got it. Okay. 256. 17 squared. Okay. We used to have to memorize all this, you know. We had to memorize all the way to 20 squared. 289. Yeah, you could. 289, you can use a calculator. And then 19 squared. Oh, you did 19 squared. Oh, okay. Oh, 324. Yes, 324. Yes, it is. And then 19 squared, you got 361. Yes, you got it. Okay. And then 20 squared, it is 400. Okay. So it comes in handy if you can remember those perfect square number up to 20 square. Okay. I used to have to do that. Okay. All right. But at least for you guys, I think it's better that you can remember all the way to 15 square. That would be great. Okay. Okay. Now, we're going to do factoring today, okay? Now look at this one. This one is the difference of this chain. It's the difference of this and this, right? So this one has a square over here. So I'm thinking, can I write this as a difference of two square, right? So is it possible I can write this as difference of two square? Well, the first one is a square of 7x, right? 7x. And 121 is a square of what? 11, right? 11. So indeed, it is a difference of two square, okay? So if it's a difference of two square, then we can factor that into two factor, okay? According to that formula, difference two square formula, right? Remember? Okay. So if you have difference of two square, you can factor that into the difference of the base here, subtract this base here, times the base over here, adding the base over here, right? So we can factor this into 7x subtracting 11 times 7x adding 11. So different two square can be factored this way, okay? Okay, now, so we done this factoring. What about the next one? The next one over here, it is, looks like the exponent over here, it is, you have an even exponent on this variable, right? This one is also even exponent, okay? So I'm thinking maybe this could be difference of 2 square, okay? So let's try that, okay? See if I can write the, are you guys able to see my screen?
Yes, I am.
Huh? Yes?
Yes.
Okay, good. Yeah, I think so. Yes, you're able to see it. Okay. Okay, so which means, so what can I write inside this parenthesis? So 64a squared is a square of what?
8a.
Yeah, 8a squared. Yeah, you got it. Okay. And then the second one here inside the parenthesis, it is what? 5b, right? Okay. Okay. So this one here indeed is a difference of 2 square. So we can factor this. Okay. So what should I put as the factors? What should I put here and here? Everyone?
8a squared minus 5b.
8a squared minus 5b, right?
And
Subtract the
8
base.
squared plus 5b.
8x squared plus 5b. Good job. Okay. All right. So if you recognize it's a difference of 2 square, you can factor them into 2 factor. Okay. Subtract the base here, add the base over here. Right. Okay. Good. Okay. Now the next one over here. Okay. Now notice that exponent on this x here is even. The one over here is also, you can also write it as 1 square, okay? So I'm thinking like, can I write this as a difference of 2 square? The first one is a square of x square. 1 is the same as 1 square. 1 to the any exponent, okay, is equal to 1, right? Okay, so note 1 square is the same as 1. Okay, so you can put any exponent on 1, you still get 1. So now after that, this is a difference of 2 square. So we can factor this. And what does this become? What are the two factors?
X squared minus 1.
Square minus 1.
And x squared plus 1.
You got it. X squared plus 1. Okay, good job. Now we're not done. Remember, when you do factoring, we want to do it completely. Okay. So over here, okay. So this one over here, we recognize this again is a difference of 2 squares. So we had to continue. Okay. So this one over here, it is a square subtracting a square again. It is x squared subtracting 1 square. So again, it's difference of 2 square. So we will continue factor, okay? And what does it become? What are the two factors?
X and 1.
X minus 1, yes, good job. Times what? X
Plus 1.
plus 1. Yes, we got it, okay? X plus 1. Now, what about the second part over here? This second factor, x squared plus 1, it is a prime polynomial. And sometimes we just call it prime. Okay, which means it cannot be factored by integers. Okay. Okay. So what we do here is we will just copy that down. So no change. So just copy down. Okay, so x squared plus 1, you just copy it down right here. Okay, now you have factored this expression here completely. You can't factor it any further using real number. Okay. Okay. Now some of you might kind of puzzle with this. How do you know this one cannot be factored, right? How do you know this is a prime polynomial? I can tell you a pattern. X squared plus any positive number, that it is a prime polynomial. Okay. It cannot be factored by real numbers. Okay. By real numbers. Okay. All right. Some of you say, "Oh, can you explain why?" Just try a little bit. Okay. So let me think about this. Let's think about this. Okay. So x squared plus 1. Okay. Remember when we try to do try and error factoring, right? So you have to think about two numbers multiplied to be 1. Okay. And then sum to 0 over here. When you don't have the exchange in the middle, right? So you can put 0 times x. 0 times x is 0. So x squared plus 1 is the same as this. So you think about two numbers, multiply to be 1 and sum to 0. Well, in order to multiply to be positive over here, the two factors had to have the same sign, either both positive or both negative. But if both of them are positive, they don't sum up to 0. If both of them are negative, they don't sum up to 0 either, right? So there's no way you can have two numbers multiply to get this positive number and sum to 0 in the middle, right? So we cannot factor this. You can actually prove it, okay? But we might be a little bit longer, okay? So x squared plus 1 is a prime polynomial, cannot be factored by real number. You can factor that by something called imaginary number, but we are talking about real number right now. So we say that it's a prime polynomial, okay? So notice x squared plus 1 is not the square of x plus 1. Remember the square of x plus 1, this is a perfect square. It should have 3 terms. Expand this, we get x squared plus 2 times x times 1, the middle term, plus 1 square, right? So this is not the same as this. This one has x squared plus 1, but also has 2x in the middle. This one just has x squared plus 1, okay? Now, some of you still have a hard time think about this. These two are not equal. Let's try to think about in terms of money, okay? Say x is $1, okay? So x squared plus 1 will be $2, okay? Now, what about square of x plus 1? So you have square of 1 plus 1, which is equal to $4 over here. So $4 is different from $2. So definitely they're not equal, okay? So don't make this mistake. Otherwise, I'll give you $2. You have to give me $4, okay? Question? Okay. Now, x squared plus 9, x squared plus 100, those are all prime polynomial. So you have x squared plus any positive number over here. Then it's a prime polynomial. They cannot be factored by real numbers. So it has to go to imaginary numbers. So those are called prime polynomial. And then when you do factoring, you just leave them alone, okay? Now let's try to compare a squared minus b squared with a squared plus b squared. A squared minus b squared can be factored into, what does it factor into? Anyone? The formula we learned today? What are the two factors? Are you guys there?
A minus b and a plus b.
Right, so it factors into this a, okay, you have AB here. The first one here is subtraction, the second one is addition, right? Okay, okay, now what about a squared plus b squared? This one over here, it is a prime polynomial, okay? So it is prime, okay? Notice that over here, it is the, see over here, it is the sum. Okay, you're taking the sum of the two square. It's important. Okay, so remember that it is a prime polynomial. So it's a prime polynomial. Of course, it's after we take our greatest common factor. So first you take our greatest common factor of the two. If there's no greatest common factor, then it is a prime polynomial. Okay. Now let's practice on this. Okay, so this to the 4 power, subtract this to the 4 power. And notice that it is even exponent right here, right? So I'm thinking I can write this as difference of 2 square. Okay, so the first one is the square of what? X plus y square, right? The second one is the square of z square, okay? Okay, good. I saw your answer in the chat. Okay, that's good. Okay, so indeed that is the difference of 2 square, okay? Because we're in intermediate algebra now, so we have this more complicated expression to factor right here, okay? Now, this is difference of 2 square. A square here, subtract a square here, so we can use a difference of 2 square formula, okay? So what does that factor into? Well, you take the base over here, which is x plus y square, and you take the base here, which is z square. So x plus y square and z square over here. The first one here will be the difference of the two base. The second one is the sum of the two base. So you factor that into this two factor right here, okay? Now this part here, you can continue to factor because it is again, is the difference of the square here and the square here. So it's different than 2 square. So we can continue factor this. So difference of 2 square again. So we can factor this. What does that factor into? Anyone? Everyone? The first one will be, well, you take the base. Again, you take the base over here, take the base over here, right? The base here, it is x plus y. The base here is z. So x plus y, and this is z. Then the first one here will have subtraction between them. The second one will have addition between them. Okay, so factor into this too. Okay, the second one over here is a prime polynomial. Remember when you have sum of 2 square, okay, there's no greatest common factor, right? So we take, so sum of 2 square here, this is a prime polynomial, okay? So this is prime polynomial. Okay, so we just copy it down. Okay, so we got this x plus y square plus z square. So we just copy it down. Okay, no change on that one. So difference 2 square could be factored. Sum of 2 square, if there's no greatest common factor, then it is a prime polynomial, and you just copy it down like this. It looks kind of long, and right, but you did it. Okay, just do it step by step. Okay, okay. So you have to factor all the way down until you cannot factor that any further. So over here, I have a different 2 square. Again, this is a different 2 square. Then you have to continue to break it down to factor that. Okay. Okay, number 2. Here. Okay, remember the first step in factoring. What's the first step in factoring?
Take out the greatest common factor.
Yeah, it's to take out the put it in y order and take out the greatest common factor, right? First step in factoring is to take out greatest common factor. Now over here, this is in y order because according to the power of x, this is the highest power of x here, right? So this go first and then this later. So now we're going to take out the greatest common factor. So what's the greatest common factor?
2y.
You got it, 2y, okay? So 2y. Now after we take out 2y, we'll have x to the 4 minus 16 inside the parenthesis, okay? Okay, let me put it on this side, note. X to the 4 minus 16, it is different than 2 squared. What should I put in this parenthesis and parenthesis over here? X to the 4, it is the square of x
squared.
square, yeah. 16 is the square of 4, so indeed it's different than 2 squared, okay? So over here, we'll have 2y, and then we factor this using the different 2 square formula. So we got x squared here, 4 here, x squared here, 4 here. This is subtraction, and this is addition between them, okay? Now let's see if any of this factor could be factored any further. Which one could be factored further? The 2y is not, right? It's already, we're down to the first power, then we cannot factor that any further, okay? What about this? Can you factor this any further? Oh, x squared minus 4. Yes, you got it, okay? So x squared minus 4 could be factored, okay? It's again different to 2 squared. Okay, let's go ahead and write that, okay? So what does it factor into? We know it has the x, right? One is minus, one is plus. Plus what?
Minus and plus 2.
2? Yes, you got it. It's a 2. Okay, 2 and 2. 4 is a square. Okay, notice that over here. Let me write it on this side. X squared minus 4. That's the square of x. And then this is square of 2. So don't forget this is a 2 over here. Okay, so you got this. Okay. Okay. Now what about this part right here? This part over here, it is a prime polynomial. X squared plus a positive number is a prime polynomial. Okay. So we just copy it down. X squared plus 4. This is prime polynomial. Question over here. You guys good? Okay. This is different than 2 squared. Okay. Now I'm going